It's 2022 and we're still stuck in a world where people are forced to be home. This means that people are also working from home. According to studies by BMC Public Health published in 2020, each office worker spends around 67 to 72% of their working hours sitting. Assuming that typical workday is 8 hours long and you're working 5 days a week, this means that you're sitting about 27.8 hours during your work time. And according to the same study, 50% of people spend their leisure time sitting as well. It's safe to say that we're just not active enough. Why would you need to be active? According to National Health Service, studies have linked excessive sitting and inactivity to obesity, slow metabolism that leads to high sugar and blood pressure levels. You're probably asking, how should we stay active during work hours then? There are multiple apps for Windows, Mac, and Linux that might help you with that, but there's a catch. All of them are fancy notifications every X amount of minutes, and you can skip them without moving away from your PC. You might listen to the notifications in the beginning when you start to use the app, but after a while you will notice that you are skipping them every time. So what's the real solution? Well, let's try to solve this problem with AI and some cheap hardware that we might have already, and that will force us to do squats. The idea here is that we will disable the keyboard and mice until you do configured amount of squats once every configured amount of time. To build this, you will simply need a webcam, USB hub, relay module, Arduino with USB connection, 10K resistor, and a push button, and some miscellaneous tools like soldering iron, knife, and screwdriver. The first thing you need to do is modify your USB hub so that we can turn off the power for it. There are two ways to do it. If the USB hub is powered, then you have to find the 5V trace, cut it, and solder the wire to each side of the cut trace so we can splice the relay in that way. If the USB hub is not powered, you can just cut the 5V line on the USB wire and splice the relay in like that. Same as I'm doing right now.
Never break, always fight, never quit, do it right, play the game, win it life, have no shame, there's no time, feel the pain, live the grind, I could change, in my mind, pick a lane, commit and climb, the only way to win it life, I never miss, that's fact, taking big swings, bitch, hand me the bat, put me in the ring, you'll go out in a bag, cause I sing what I mean, and I bring it to the mad light.
This is the full circuit on how everything goes together. Since I didn't have Arduino Uno or Arduino Pro at hand, I used Arduino Pro Mini with an FTDI adapter. Note that we have a pull-down resistor in the schematic on the signal pin for the 5V relay. It's there to avoid floating voltage when Arduino boots up, as it puts the pin in input mode, and if there is no pull-down resistors, it will float and turn on the relay, and we don't want that. Normally closed terminals on the relay side are connected to our modified USB hub. So when the relay is off, there is the power to our USB hub, and when the relay is turned on, there is none. I also added a push button that will be used later as a snooze button for the activity reminder. After the connections are made, I wrote the firmware. The Arduino code is super simple. It just takes and configures the defined button pin, in this case 10, as an input with an internal pull-up resistor, and the relay pin 13 as an output pin. Then it opens up the serial port and sends a JSON message on each button press and waits for JSON message to enable and disable the relay. After the hardware and Arduino firmware was done, I needed to write a desktop app that will communicate with the hardware, count down the time, and analyze camera data and count squats. To analyze camera data, I used OpenCV and I used Mediepipe to track pose landmarks. Now that I have those landmarks, now what? Well, there are two options on how to proceed. use the hip thing called machine learning, and then train a classification network for each exercise type we need to support. In this case, that would be squats, or use simple trigonometry to calculate if the user is squatting. For this, I'm assuming that the user is squatting if the average value between both leg knee angles is less or equal to 19 degrees. I have used this app and hardware combo for a week now, and I have learned a few things. I'm out of shape. I always did squats and never thought to replug USB wires, possibly because I'm lazy. The software has some issues. Seems like OpenCV causes a crash when the camera is opened by another app. There's a bug in the way I detect squats that counts my face as a squat if I'm too close to the camera. Window size is increased and the resized back is not working as expected. Also, hardware takes too much space on my desk. If I want to do squats before meeting to increase time, there is no way to do that right now, so an additional button should be made. In future version of this project, if I decide to make one, or if you want to see one, I would consider the following improvements. Custom PCB that contains USB hub and Arduino and everything else that's needed for it to run. Additional button to do squats now, so there are possibilities to snooze and do the squats before the time runs out. Fix annoying issues with the app, like resize, inaccurate detection. More exercise types like squats, push-ups, etc. I hope you enjoyed this silly video. If you have any suggestions, please leave a comment down below. There's also a link to the source code and the research data in the video description. Thank you for watching, and I will see you next time.